The important numerical part in the electrochemistry, there is a Nernst equation. Nernst equation or Nernst equation, this is very important. So, it gives the information or it gives the relation between electrode potential or cell potential, nothing but EMF. Potential to the concentration change or temperature change. Concentration means it may, for a solution we can take molarity, for gases case pressure. Concentration and temperature change, that is an Nernst equation. So, let us take one cell reaction, example 1, normal cell reaction, a general cell reaction like this, AA and BB gives rise to CC and DD. Here, according to the thermodynamics data, you can write the thermodynamics relation for this, that is delta G is equals to delta G naught plus 2.303 RT log Q. What is the Q here? Reaction quotient, that is a product's concentration by reactants concentration according to chemical equilibrium. And from this we know that delta G, what is the delta G? Minus NF E cell, that you substitute here, and delta G naught minus NF E naught cell plus 2.303 RT log Q, a reaction quotient. So, from this E cell is equals to, you can bring this NF this side, NF will cancel out, you are left with E naught cell plus 2.303 by NF, this is 2.303 RT by NF log Q, and this is called Nernst equation. And by using this Nernst equation, we can calculate the cell potential or electrode potential at any condition. Anyhow, E naught cell, this is a standard condition, and if you change the temperature or if you change the concentrations, you can calculate by change the concentration values of reactant and product and the temperature change. Those values if you substitute here, you will get the E cell of that particular electrode or cell, whatever it is. Sorry, this is negative. This one is negative. This you can correct it, it is a negative. And further, and you can write this temperature generally we can keep constant at 25 degrees centigrade. Most of the cases they will give the problems at 25 degrees centigrade. If you change the temperature, you can change it, but mostly about 95% cases you can see the calculations at 25 degrees centigrade. At 25 degrees centigrade, and this value you can write 2.303 by RT by F. It can be write as this is 2.303 and R gas constant 0.0821, temperature 298 kelvins, and Faraday, 1 Faraday is equals to 96,500 coulombs. And those value if you substitute here, you will get finally this is 0.0591, means in place of 2.303 RT by F, you can write this 0.0591. So, the final equation you can write like this: E cell is equals to E naught cell minus 0.0591 by n, where n nothing but number of electrons involved or number of electron transferred in overall chemical reaction by log Q, and this is an Nernst equation where n is the number of electrons, n nothing but number of electrons involved or number of electrons transferred. We can see one example here. Let us take one Daniell cell equation. Zinc and copper 2 plus can give zinc 2 plus and copper. For this, if you apply the Nernst equation, you will get E cell is equals to E naught cell minus 0.0591 by number of electrons involved here 2 electrons, n equal to 2 log. Now concentrations of products, what are they? Zinc 2 plus concentration by copper 2 plus concentration. Copper is a solid. For pure solid, the concentration is unity. So no need to take here. And again zinc, concentration of zinc is unity and concentration of copper 2 plus. These are the ions. So this is an Nernst equation for this Daniell cell. This is in terms of concentrations. If they use in terms of the gases, let us see one more example. Gaseous reactants. H2 plus copper 2 plus can give 2H plus copper. Let us take like this. Your hydrogen is a gas, they will give the partial pressure of the hydrogen, and copper anyhow concentrations, and this is H plus concentration, copper is a solid. And for this case, the E cell is equals to E naught minus 0.0591 by again number of electrons involved 2 log of concentration of H plus, and your stoichiometric coefficient 2 is there, so H plus power 2, copper anyhow solid unity, and now partial pressure of hydrogen you have to take. In place of hydrogen, the concentration is partial pressure, and concentration of copper 2 plus. This is in terms of molarity, and this is a Nernst equation with for this equation where the gases reactants involved. So here applications of Nernst equation. The main applications here, we can identify the non-standard reduction potential values. Anyhow, standard reduction potential values we can calculate by using the standard hydrogen electrode, but to calculate the non-standard reduction potential values, means at different temperature and different concentration conditions, you can use this Nernst equation to determine non-standard either electrode potential or cell potential. Non-standard electrode potential or cell potential. We can use this Nernst equation like this. Cell potential means the previous examples, and electrode potential means single electrode for off cell reactions. If I take one reduction reaction or oxidation reaction, let us take one oxidation reaction or oxidation of cell, oxidation potentials. Oxidation potential. Here you can take one metal, it is giving some n electrons. So for this particular equation, if you want to write the Nernst equation, E cell is equals to E naught of this particular metal minus 0.0591 by number of electron transferred n and log of concentration of Mn plus. And here this E value is called E oxidation potential is equals to E naught of that particular electrode oxidation potential at standard condition, and this if you bring outside minus minus plus you can write this 0.0591 by n log of concentration of this ion, and this is the oxidation potential calculation for a given electrode at any condition. But here temperature is constant, we are varying only the concentration, and if you draw a graph you will get the graph. Sometimes they may ask you the graphs. If you take the graph with the E oxidation potential versus concentration of the electrolytic solution versus E oxidation potential. So for this, how will you get the graph? The graph is look like y equal to mx. So you will get the graph like this. Oh, sorry, I wrote wrong this one here. This is power only, direct only. I wrote reduction potential values. This is minus only. Just you can please correct it. And this is oxidation means Mn plus, it will come upside. The product side, product by reactant. So product is Mn plus, reactant is M, that will cancel out. So this is log, this is minus only, not plus. A small correction here. Okay, so you will get now the negative graph like this. So y equal to minus mx plus c. So now slope is here minus 0.0591 by n. This is the slope. I intercept, and this is a point, and this is E0 of oxidation. This is oxidation potential calculation from for a cell by using the Nernst equation. Similarly, you can calculate the reduction potential also for off cell. We can take just a reverse the equation, Mn plus n electrons can give M. Then again, if you apply the Nernst equation for this, E equal to E naught minus 0.0591 by n log of. Now here you will get concentration of metal. This is unity by concentration of metal ions. So this one, and here this E value. What is this reaction? Reduction reaction. So the resultant E is the reduction potential. E reduction is equals to E naught of reduction potentials, and here you can take this denominator into the numerator part, then you will get minus minus plus 0.0591 by n and log of concentration of metal ions. This is the reduction potential values. Or else you can take this directly from here to here. What is that? E oxidation is equals to negative of E reduction. You can write this negative, you can take and you can convert. And this again the graph for this. And E reduction versus concentration of metal ions. This is a y equal to mx plus c, you will get a positive slope. The previous case you will get negative slope, here positive slope, again the same intercept, but this is E naught of reduction, and the slope is here positive slope 0.0591 by n, just quite opposite to the previous. Anyhow, the magnitude is the same, but sign is different for both oxidation and reduction potential values. This is one application, identification of non-reduction potential values of a particular electrode or overall cell. And the second application, to determine the equilibrium constant. We can determine the equilibrium constant by using this Nernst equation. Equilibrium constant. Again, you write that overall cell equation for a particular cell reaction, E is equals to E naught minus 0.0591 by n log of Q. This is the general Nernst equation. We know that E cell equal to E naught cell minus 0.0591 by n log K. But at equilibrium condition, H equilibrium, we know that reaction quotient Q is equals to equilibrium constant. Right? At equilibrium, Q equal to K equilibrium, and also at equilibrium condition, E cell of reaction equal to 0. Why? Because delta G is equals to 0 at equilibrium. Delta G equal to minus N of E cell. So, E cell also should be 0 at equilibrium condition. These values if we substitute here, we will get 0 is equals to E naught minus 0.0591 by n and log of K equilibrium. And from this E naught value, we can calculate the oxidation, that is a standard reduction potential values by knowing the equilibrium constant. That is 0.0591 by n. This is also one of the important formula. Log K equilibrium at equilibrium condition. So, this is a formula. E naught equal to 0.0591 by n log K equilibrium, and this we can write further. Log K equilibrium is equals to n is 0 by 0.0591, and if you remove this log, K equilibrium is equals to 10 power n is 0 by 0.0591. So, this is the equilibrium constant calculation. This formula also very important. So, like this we can calculate the equilibrium constant by using the Nernst equation. We will see one question. For a cell reaction like this, zinc 2 plus whose concentration 0.1 molar, copper 2 plus 0.01 molar copper, and whose reduction potential values are like this. So, this is 0.6. Now, calculate E cell. Calculate E cell. How to do here? First, you have to write the cell reaction. So, for this, the resultant cell equation is zinc copper 2 plus will gives zinc 2 plus and copper, where the concentration of copper 2 plus 0.01 molar and the zinc 2 plus is 0.1 molar. Now, resultant E cell. And before that, E naught we have to calculate. E naught equal to E cathode minus anode, that is 0.8 minus minus plus 0.76. 1.56 is the resultant E naught value. This you can write E cell is equals to, now E naught minus 0.0591 by number of electron transferred here is 2 log zinc 2 plus concentration by copper 2 plus concentration, and here E naught is 1.56 minus 0.056, you can write approximately as 0.06 by 2. Zinc 2 plus concentration is 0.1 and this is 0.01. That overall you will get this is 0.1 by 0.01. This is overall log 10 is 1. So, resultant value 1.56 minus 0.03. So you will get E cell value is 1.53 volts. So like this we can calculate the resultant value if we change the concentrations of electrolytic solutions at different concentrations. So EMF of this particular cell and whose reduction potential values are given, and pH of HCl and hydrogen partial pressure. In this case, how to calculate? Again, you can write the cell equation. This is zinc plus 2H plus. You can give zinc 2 plus and H2. Where 2H plus concentration pH2. pH2 means concentration is 10 power minus 2 molar, and zinc 2 plus concentration, and this is given as 1 molar here, and this is 1 molar. Partial pressure of hydrogen 1 atmosphere. Now resultant E cell. E cell is equals to E naught cell minus 0.0591 by number of electron transferred to log of zinc 2 plus concentration by partial pressure of hydrogen and H plus concentration power 2. And what is the E naught? E cathode minus E anode. Here E naught is equals to E cathode minus E anode. What is a cathode? Here hydrogen electrode is a cathode. For hydrogen electrode, the SH is 0, there is the electrode potential. So E naught is equals to minus of minus. You get 0.76 volt, that you can substitute here directly. Then E cell is equals to 0.76 minus, this is approximately 0.606, so you can write 0.03. Log of zinc 2 plus concentration is 1, partial pressure of hydrogen is 1, H plus concentration 10 power minus 2, power 2 means 10 power minus 4. So that can give the 10 power 4, 10 power 4 means 4. 0.76 minus 0.03 into 4. The resultant value, this is 0.03 into 4 means 0.12. You can subtract from here, you will get 0.64 volts. That is the resultant E cell value.